Alright, your piping inspection code, inspection repair, alteration, re-rating of Inservice piping system, American Petroleum Institute 570, second edition, October 1998. Alright, chapter 6, frequency, extent, and inspection. General, the frequency, extent, and inspection of the piping circuits, depending on the form of the degradation that can affect the piping with the consequent of the piping failure. With the variation of the degradation cause can affect with the refining piping circuits are described in 5.3 simplified classification. Piping based on consequence failure with the defined 6.2 as described in 5.1 inspection strategy based on the likelihood consequent failures referred to risk-based inspection. Simplified piping classification scheme of the section 6.2 based on the consequence of failure classification used to establish frequency extent with expansion. Inspection owner and user may devise more extensive classification scheme more accurately assess for the consequence of the tree and piping so for the consequent assessment would be considered the potential explosion, fire, toxicity, environmental impact, other potential effects associated with the failure. An effective assessment is conducted the result that can be used in establishing piping survey inspecting strategy. More specifically, better to define and follow the most appropriate inspection method, the scope of the tools of the techniques to be utilized based on the expected forms of the degradation, appropriate inspection frequency, need of the pressure testing after damage has been incurred with after the repairs modifications have been completed, preventive mitigation steps to reduce likelihood of consequent piping failure. A risk-based inspection assessment should be made and to increase the decree for the inspection listed in table 6.1. Similar extent of the inspection may be increased to dependent degrees beyond the target label of table 262 with the risk-based inspection assessment. We use to increase the inspection interval time, limited extent of the inspection. Risk-based inspection assessment should be conducted with internal intervals not to exceed the respective limits of the table 6.1 or more often warranted process. Equipment to consequent change of the risk-based inspection specimen should be reviewed with approval of the piping engineer, authorized piping inspector at intervals not exceeding the respective limits. Table 6.1 are often warranted by process equipment and consequence changes. 6.2 piping surface classes. A process piping system should be categorized in different classes, such for the classification system allows extra efforts for the inspection efforts to be focused on the piping system that may have high potential consequent failure, loss, content that should occur within general high classified systems require more extensive inspection or shorter intervals. In order to affirm the integrity of the continuous safe operation, classification should be based on potential safety environmental effects should a leak occur. Owners and users should maintain the record process piping fluids handled, including their classification API recommended practice 750 and the National Fire Protection Association 704. Provide information may be helpful classifying piping system according to the potential head of the process of liquid fluids they contain. Three classes listed below are 6.2 through 6.3 are recommended. Service of the high potential result of the immediate emergency if the leak will occur to class 1. Such an emergency may be safe to the environmental natures. Class 1 piping include but are not necessarily limited to those containing the following. Flammable surface may auto refrigerate and lead to brittle fracture pressure. Surface rapidly vaporize during release, creating vapors that may collect and form an explosive mixture such as C2, C3, C4 streams. Hydrogen sulfide greater than 3% weight with a gaseous stream and hydrogen chloride, hydrofluoric acid piping over adjacent water piping, other public water throwaways refer to the Department of Transportation, U.S. Coast Guard regulations, inspection over water piping. Class 2, surface does not include with the other Class 2, the classification include with the majority of unit processing piping, selected off-site piping. Typical examples of surface include the containing of the following. On-site hydrocarbons will slowly vaporize during release, hydrogen fuel, slow gases, natural gas on-site, strong acid, caustic. 623 Class 3 surface flammable do not sufficiently vaporize when they leak and are not located with the high activity areas. The last three surface potential harmful to the human tissue located with the remote areas are be included in the Class 3. Examples of Class C surface are as follows. On-site hydrocarbons will not significantly vaporize during release. Distillated or in product lines to and from the storage loading. Off-site acidic and caustic. 6.3 inspection intervals. The internal interval between the piping inspection should be established maintaining the following criteria: corrosion rate, remaining life calculations, piping for the classification applicable to jurisdiction requirement. Requirements judgment of the inspector piping engineer, piping engineer, supervisor, corrosion specialist based on the operating condition. Previous inspection here is history, current inspection, and resolve of the conditions that may warrant a supplemental inspections in 545. Owner and user of the inspection shall establish the inspection interval thickness measurement, external visual inspection where applicable, the internal and supplemental inspection. The thickness measurement should be scheduled based on the calculation no more than half of the remaining life of the determined with the corrosion rates indicated in 7 5.11 maximum intervals suggested in Table 6.1. Whichever shorter intervals may be appropriate under circumstances prior to Table 6.1 corrosion rate should be calculated in accordance with 713. Table 6.1 contained with the recommended maximum extended inspection interval for the three categories piping surface described in 6.2 as well as recommended intervals for injection points or soil-to-air interface. The inspection interval must be reviewed to the dust necessary for each inspection. Significant change of the operating conditions, general corrosion, localized corrosion, pitting, environmental cracking, other forms of the deterioration must be considered with when establishing various inspection intervals. Our extended visual, external, and corrosion under insulation inspection. External visual inspection includes inspection corrosion under insulation conducted at the maximum interval within the listed in Table 6.1 to evaluate items such as those opposed in Appendix B and D. External visual inspection of the bare piping to assess for the condition, paint, and coating system, and check for the corrosion, check for the other forms of deterioration. External visual inspection for potential corrosion under insulation. Also, assess the insulation conditions should be conducted on all pipe system and piping systems suspect with corrosion under insulation listed in 53331. Following external visual inspection, suspect will assist with additional examination as required with the inspection of the corrosion under insulation. Extend with the type of the additional under corrosion and under insulation inspection listed in Table 6.2. The damaged insulation higher revelation this may result in the corrosion under insulation in lower areas removed with the damage. Non-destructive examination inspection for a corrosion under insulation should also be conducted listed in Table 6.2. The suspected locations 5332 excluding C, meeting the temperature required terms 5331 E, F, and H. Radiographic examination installation removal visual inspection normally required for this inspection. Damage suspected location other non-destructive examination assessments may be applicable if the inspection damage is subject to areas located with the corrosion under insulation. Additional area that should be inspected where warranted. Up to 100% of the circuits should be inspected. The extent of the corrosion under insulation program determined in Table 6.2 should be considered as target level of the piping system. Locations of no corrosion under insulation inspection experience. It recognizes several factors may affect the likelihood of corrosion under insulation and include local climate conditions, insulation design, coating, quality, surface conditions. Alright, facility for the corrosion under insulation inspection experience with the main crew for the under-reduced the corrosion under inspection and inspection targets. Table 6.2 is active accordance with the corrosion under inspection. Inspection targets are not required. Owner and user may conform inspection targets with the operation history and other documents. Piping system that are known to have the remaining life over 10 years. The adequate protective against for the external corrosion not included with the non-destructive examination recommended with the Table 6.2 have with the condition insulation for the outer jacketing of the cold box shell, but it should be observed periodically, obtaining the other personnel with deterioration noted. It should be reported to the inspector for the following example of the system piping insulated with the effect of the preclude the entrance of moisture, jacketed cryogenic piping system installed with a cold box within which the atmosphere is purged with the inert gas, piping system with the temperature being maintained with a sufficient low and high pressure to preclude presence of water. 6.5 extent of thickness measurement inspections has satisfied the inspection interval requirement that each thickness measurement inspection should be obtained with the thickness reading of the representative of the sample with thickness measurement locations on each circuit. C5.5 the representative sample should include the data all the various types of the component for the operations orientations horizontal, vertical, the bound of each for the circle. The sample also must include thickness measurement locations with the earliest renewal date with the previous inspection. More thickness measurement locations measured for each for the circuit with the most accurate the new inspection date will be projected. Therefore, schedule an inspection of the circuit should obtain many measurements as necessary. The extent of the inspection for the injection points covered in 531.66 extent of the small bore auxiliary piping thread connection inspection. Small bore piping inspection. Small boring piping is primary process should be inspected in accordance with the requirements of this document. Small boring piping. Secondary process piping to different minimum requirements depending on the service classification. Class 1 secondary service bore piping shall be inspected the same requirements for the primary process piping inspection. Class 2 and 3 secondary small bore piping is optional. Small bore piping dead legs so the level of the brittles in class 2 and 3 systems should be inspected with the corrosion has experienced anticipated. 6.62 auxiliary piping inspection. Inspection secondary with auxiliary small bore piping associated with the instrument machinery operational condition. Critical consideration in terms of the auxiliary small bore piping will need some form of an inspection, including the following: classification, potential of the environmental fatigue, cracking, potential corrosion, base experience with the adjacent primary system, potential for the corrosion under installation, threaded connection inspections. Inspection of threaded connection would conform with the requirements listed above with a small bore auxiliary piping with select thickness measurement and location of threaded connections, including only those with the radiographic during scheduled inspection. Threaded connections associated with the machinery subject to failure, fatigue, damage. They should be periodically assessed with a consider of the possible renewable thick wall, upgrading the welded components. Schedule such renewal will depend on several issues of the following: classification, pipe, the magnitude, frequency of the vibration amount of the unsupported weight, current piping wall thickness, whether they're not the system can be obtained on stream corrosion rate and intermittent services. Table 6.1 recommended maximum internal volts type, the surface thickness measurement. Class 1, 5 years. Class 2, 10 in 5 years. Class 3, 10 in 10 years. Decision points 3 years by class. Soil to air interface by class. No thickness may apply with the system of the table measure. The thickness measurement established in accordance 5.5, C531, B, C534, Table 6.2, recommended extent corrosion under inspection. Following visual inspection proximate amount of the following examination: non-destructive insulation, removal of the air with the damaged insulation product, spent amount of the corrosion under insulation inspection for the non-destructive examination. Suspected areas 5332, piping system with suspected temperature range 53325 an H. Pipe class is 1, 75%, 50%, 2, 50%, 33%, 3, 25%, 10%. Inspection, data evaluation, and analysis from recording. Testing.